Um, Bruce has been asking fairly consistently, how safe are our vehicles, right? And I have a twist on that question, right? How safe is safe enough, right? And specifically in the AV context. And, if we look at the way this is handled today, right? It's effectively a corporate decision, right? Waymo decides how safe is safe enough. Zoox decides how safe is safe enough, right? And what I'm asking is the provocative question of, should it be a corporate decision or, should it be a societal consensus, right? And I wanted to sort of do a quick sort of thought experiment here to sort of get your mind started on the idea that I think it's a societal consensus because we all have opinions on this. And so let's do this thought experiment where we go forward into the future to a world where AVs are now pervasive. Um, and there's two potential headlines that would exist at the same time potentially in this future. One of which would be the really great one, which we all want to see, which is that, we've talked about this humans creating, being at fault for sort of 94% or something. So let's just say autonomous vehicles taking drivers out of the loop. Let's say they could reduce fatalities by 90%, right? Today, that takes our number from something like 40,000 a year down to 36, or down by 36,000, right? And that's amazing. Think about that, right? 36,000 people alive at the end of each year that wouldn't have been if AVs had never come along, right? But there's the other headline that is equally plausible, right? Because it's 90%, it's not 100%, right? So AI robots could kill 4,000 people per year in the United States, and we wouldn't be able to explain why, right? Because it's not a societal discussion, right? It's a closed indoor corporate decision. And AI networks, just by their very nature, are black box, right? So if you go to the engineer and say, why did this happen? They say, hey, I can't exactly tell you because it's a great big AI network end to end and it's a black box. And then you say, okay, well, can you make sure it never happens again? And they say, well, I can retrain the network with a bunch of new data, but I can't give you a solid deterministic guarantee that this won't happen again because this is probabilistic. So, that's going to be unsettling, right? That's not a comfortable headline to think about. So, that's why I think it needs to be this more societal, shared walk together into this future, right? Where we're all sort of walking arm in arm saying, yes, this is what we want to do, so that we can get the good headline shown there in yellow and not get the massive backlash that would be caused by the blue box there. And so let's talk about who wants to know, like in this wider societal discussion, who's asking the question, how safe is safe enough? Well, the general public is, right? They want to know, is it safe for me to get into a Waymo robotaxi? They want to know, is it safe for me to step in the crosswalk in front of a Waymo robotaxi, right? Public safety advocates need to know so they can advocate for proper safety. Regulators, especially permitting authorities or DMVs that have to say it's okay for these vehicles to operate on these roads, they need to understand how safe the vehicles are. If accidents happen, which they will, and go to litigation, judges and juries need to decide fault. Insurance companies need to understand risk so that they can properly underwrite that risk. The AV companies themselves want this sort of discussion to happen as well, because if an AV company can say, I designed my system to meet these standards, then that actually gives them some buffering in the sort of inevitable reputational shocks that come with accidents and injuries. Mobility providers like Uber and Lyft, if they put an AV provider into their mobile app, they need to understand, the safety of that mobile or that autonomous vehicle that they're putting into their ride-hailing app. Investors, right? AVs are currently not profitable. they live on investment money, deep pockets. And so the people with the deep pockets, need to understand, should they keep investing? And so, let's talk about, how this set of potential frameworks could roll out for having this discussion. Everybody wants zero risk, but as is shown in the bottom corner there, zero risk is impossible, right? So it's really a discussion about absence of unreasonable risk. And that's why this is a consensus process. And, there's this model we all have in our head of, there's a regulatory framework that might be a good cop, and there's another one that's a bad cop. And a lot of people think, and especially at the sort of innovator end of the tech space, people think of regulation as a bad cop, right? That's just sort of a knee-jerk reaction. And so they say, I really don't want a bad cop. And they would actually prefer the situation of no cop, which is sort of de facto where we are right now, right? But I would say this is really a false situation because there really isn't no cop. There's a litigation cop, right? Because when the vehicles cause accidents, it goes to litigation. And then a jury of our peers decides what's right and wrong, which actually is not as good a way to decide right and wrong as a societal consensus. Or every state does their own thing, right? Each DMV makes its own set of rules, and then you end up with 50 cops, right? So no cop is really not a good situation, despite the fact that some people say they would prefer that. So we really got to think about, what does it take to get to this good cop that we're all in agreement, is positive for innovation, will deliver the safety benefits of AVs, but also bring society along on this journey with us. And, Waymo did a really great thing last summer. They published a paper, the link there at the bottom, you can find on their 12 acceptance criteria. So whenever they make a change to the vehicle or the operational design domain that it works in, or go to a new city, any kind of change, they have to go through this 12-step process. And, kudos to Waymo. It's a very comprehensive process, right? It touches on all the things that we would want to know that they're touching on. And so some people look at that and they go, okay, well, there it is. So, what's missing? And so that's why I pulled a quote out, from this paper, where Waymo says, targets and quantitative benchmarks are not included in this paper. Minimum benchmarks need to be agreed upon broadly by industry and regulators, but only after a more precise conversation on which metrics and indicators can be used to aggregate residual risk is undertaken. So, they're telling us the categories they look at, but they're not telling us what is good and what is bad, right? And that's, I think, where we need to get to in order to have a really sort of good societal discussion on how good is good enough. So at Mcity, we're creating an AV safety assessment to sort of step into this gap. And we have some goals. We want it to be clearly defined, fully transparent, completely unbiased, and endorsed by a diverse group. Clearly defined, I think, is one of the really key ones, right? We want to specifically demarcate, this is passing, this is failing, right? So that it's not like, those kind of discussions we often see, like, in a lane change scenario, the vehicle shall handle it this way, right? That's more fuzzy than what I want, right? What I want is, in this specific scenario, these kind of gaps are acceptable, these kind of gaps are not, right? These time to collisions are acceptable, these times to collisions are not. These sort of, braking profiles would be late braking, which isn't acceptable. These ones would be overly conservative, early braking, right? So I want us to actually get to the point where we can discuss, actual pass-fail metrics. And I want us to do it in a way, that's very public, right? A lot of people sort of come up with sort of frameworks and they say, somebody should figure this out, right? And so I want this to be the spot where we figure it out. And I want us to put a public stake in the ground and say, here's our opinion. And then I want everybody to, you know, give feedback, right? Because that's the great thing about, consensus processes is we say, this is what makes sense to us. And people say, that doesn't make sense to me for these reasons. And we go, those are really good points. We should modify it to take that into account, right? And that is the process of making this all better. And that's why I think somebody needs to, put a solid stake in the ground and go first. Has to be transparent, fully open source, fully inspectable. We're not in this business to generate IP or to create a profitable business model. That's not why we're here. We're here to make something that helps us get to the future safety benefit of AVs in a way that we all agree is the right way. Third-party assessment, the benchmark for this are things like consumers reports, right? Which is, sort of a well-respected, unbiased third-party assessment group, right? We want to have that same sort of unbiasedness in this kind of a process. And it needs to be endorsed, right? That group of stakeholders that I showed a couple of slides back, right? They all need to be saying yes. If AV companies held themselves to this set of standards, that would be, a good thing that should give them legitimacy in what they're doing. And, that can be, any form, right? It doesn't have to be regulatory, right? Because regulation, we all know, takes years and years, right? It's a really hard thing. And then as soon as it gets made, it needs to be updated, and that takes years and years again, right? There are things like NCAP ratings. Those also take a while to percolate. So they're also on a not super quick route to this. But there's also, a lot of sort of history of, self-certification of people just sort of saying, I have met these standards and that is auditable. So, I think it can be anywhere on that spectrum. I'm not necessarily advocating, has to be regulation or has to be NCAP or has to be self-certification. We're sort of open to that full discussion. So one of the big things that's really held AVs back is what we call the curse of rarity. Our Mcity director, Dr. Henry Liu, wrote a paper. It's linked at the bottom of this slide, but if you just Google curse of rarity for autonomous vehicles, you'll find it. It was in Nature. And what he's talking about is the fact that, if you look at that black line, right? Towards the left side of that is normal driving, right? It's easy to make an AV work well in normal driving because normal driving happens all the time. You can get as much training data as you need in normal driving. But it's harder to train your AV when you get into the safety critical near miss events, which are much lower occurrence rates. And then accidents being sort of, 1 in a million kind of events, are very rare, thankfully, but not rare enough, obviously. Fatal accidents, we're talking about, roughly 1 per 100 million miles now, right? So you're, off the end of this chart, right? You're 10 to the minus 8th, right? And if you think about that, right, proving, capability on 100 million miles, I mean, it's really hard to do that with physical driving, right? And when you look at that 100 million benchmark, then everybody says, yeah, but that's not enough to be statistically significant. You have to get actually 300 million, right? And then other people look at that and they go, and even that's not good enough because you're using humans as a benchmark, and humans aren't a really great safety benchmark, right? Humans are causing 40,000 deaths every year on the freeways, right? So why hold them as the benchmark? Why shouldn't we be 10 times better than humans, right? And so now you're talking about billions of miles, and you're not going to drive that. And especially when you think about the fact that anytime you make a change to your software, you'd effectively have to start that mileage accumulation clock over, right? Because you've retrained your AI network, so you're back to 0 miles, right? So it's just not possible to do it physically. So there has to be a simulation component to that. And I would say for this really high mileage area, simulation is the way to go. But for the normal driving area, I think physical testing still is a very tractable solution. And physical testing has just the extra credence of it's the real vehicle in real environments, right? And so it brings some credibility. So for that, we've really developed sort of two levels of our safety assessment. The first level is the more sort of normal driving, and this would be a competency test. So this isn't every possible scenario that could happen. This is sort of analogous to if you think about your teenagers getting their license, right? This is like the driver's license test. But it gets into some safety critical near misses. So it'd be a licensing test for your teenager on a really bad day, right? So that's what we're looking at here. We would set this up at the track. We've been doing this kind of testing for, a decade now. Mcity has a lot of history with it. And it would just sort of give you the basic, assessment of competency in sort of known scenarios. But then you need to do this high mileage, hundreds of millions, maybe billions of miles worth of simulated AV stress testing. And to do that, we've created an adversarial world. And that really accelerates the testing, right? So it's not just a boring world like what most of us drive around in most of the time, right? It's a world where we've taken out all the boring bits and compressed it down in order to get test acceleration. And it would be done, completely in simulation. And so I'll talk a little bit more about both of these. First, just to hit on the physical test, right? The Mcity track, really close to where we are here today. It's a track that's been in operation for a decade now, doing autonomous vehicle testing. We have robotic strikeable test dummies. We now can generate bad weather. We have a snow gun. So on cold days, we can make snow. On warm days like today, we can make rain, more rain. So, we have autonomous vehicle platforms for the testing and full connectivity. So a lot of history at Mcity doing this kind of work. And then, for that high mileage AV stress testing in an adversarial world, we've made a digital twin we've released open source. This is the Omniverse one. You can see the reflections in the windows there, which show, I think some of the quality of the digital twin we have here. But, soft shadows, the foliage looks right. It's a much more realistic digital twin than I think we've had in the past. And the nice thing is we've released it completely open source. So anybody can go to our GitHub, just Google Mcity digital twin and click on the GitHub link, and it'll take you there, and you can download the digital twin and use it in your simulation work. And then, like I said, we've created an adversity orchestrator, which we call TerraSim, which is also open source. So that's the thing that would populate this world with all the other vehicles and pedestrians, change the weather conditions, things like that, in order to make it an adversarial test. And this is a traditional sort of game engine based mesh model approach. This one here is a digital twin that was created by Parallel Domain, which uses Gaussian splatting, which is the latest state of the art in creating digital twins. And so this is actually a simulated world. This is not a video. This never happened, right? Everything in this world is simulated. We can change anything about it. We can move the poles around. We can change the weather. We can change all those vehicles. Here in the background, you can see these cyclists over here, coming through the picture over here. So we can add all that sort of content into the digital twin. And because this is full simulation, we can modify any of it to create any sort of adversarial scenario we want. And the photorealism of it means that we can feed this directly into camera algorithms, AI models to do perception directly. So this can be the input to the end-to-end AV stack, and then the output on the other end is, steering, throttle, brakes, path curvature, XL, decel, all those sorts of things. And then the next step is, okay, the previous one I showed you was how we would do it in our Gaussian splat digital twin on the Mcity track. But, Waymo's not rolling out a robo-taxi service at Mcity, right? They're doing it in, for instance, City of Detroit, they announced they're coming to, right? So the next step is, how do we use these techniques in, say, a city scale digital twin, right? And so what we've been working on is a city scale digital twin of Ann Arbor, because we live here and it's easy for us to get data. And what we do here is we use generative AI to actually build the digital twin of City of Ann Arbor. And the steps we do in that, the first step shown up here is we use AI to extract the road network from aerial imagery, like satellite imagery, things like that. So we directly, with generative AI, extract the road network. And then we use TerraSim, that open source adversity orchestrator, to add, all the vehicles into the scene, which you can see traversing a roundabout there. And then to make it photorealistic, what we do is we take Google Street View images from those locations and we feed those into a generative AI model, Cosmos Dream Drive, created by NVIDIA. And what the generative AI does is it takes this road network and it takes this style of image and it creates video sequences of what camera data would look like to this, vehicle here traversing this roundabout, right? So that's what's created here. All of this is completely generative. It's not a video that doesn't exist. That is all created by generative AI. But we can take that, we can feed that into the end-to-end network in the AV stack and see how it reacts. So this is sort of how we grow the AV assessment so that we can do it in specific cities that specific robotaxi services want to be rolled out in. And then you got to add not only vehicles as adversity or pedestrians or cyclists, but you also got to add environmental adversity. So what we can do, again, with generative AI is we can say, okay, take this road network and generate me a scene on the roundabout, but do it on a sunny day. And then over here, do it on a foggy day. And now give me what it would look like at night. And here's what it would look like, with, rain droplets on the lens, on a rainy day. And here's a snow-covered day. And here's, where a construction zone has been set up. And again, all of this is created with generative AI, right? So it makes the process very efficient. And the combination of creating the world in generative AI and then introducing an AV into it and putting all these adversarial actors around it gets us that test speed up that I talked about, where if you take 100 million miles, just say that, use that as a benchmark to say, number of miles between fatal accidents for humans, and you take out all the boring bits in that 100 million miles, it's actually only about 10,000 miles of really, sort of adversarial events. And so that's what we're doing, is we're taking out all the boring bits, we're making it so that it's just adversarial events. And we can, by simulating 10,000 miles of driving, we can get the equivalent of 100 million miles of experience. So it's a 4 order of magnitude speed up, which is really incredible. So this is my last slide. We talked through our competency test. that'll be mainly on the track. We talked about the intelligence test that's in full simulation. And we talked about our goals for what this test will be. And again, this is a community building exercise. This is not a proprietary kind of thing, right? We are looking for engagement. We're looking for partnership. We want this to be publicly debated, fully open, and hopefully moving us on that journey to, getting the benefits of AV safety without getting the, societal disruption that we're worried about.